This is task 2, question 4 from page 7 of the Digital Electronics course notes. In this question, we have all 3 different types of our basic logic gates to contend with, and we've got 3 inputs to our system. It's indicated that we have 2 intermediate values to work out, D and E, and the final output value is always Z. So we require 3 additional columns in our standard truth table to work out these values. The values for A, B, and C given in the table are just all possible combinations of those inputs, and that standard table is found in the course notes. The setup of this diagram requires us to tackle the gates in order from left to right, as each gate's output is input for the next gate, proceeding in that direction. So we'll start off looking at this AND gate here. I'll put it in a red box to indicate which one I'm talking about. AND gates only produce a 1 in the output value if the 2 inputs are 1. And in this case, our inputs indicated in red on the table are A and B. So looking down that table, the only place we're going to get a 1 for column D is when A and B are both 1. And that happens here and here in the final 2 rows of the table. So I can insert 1s in column D there. This means that in every other row, there's not 2 1s, and therefore the output is 0. AND gates require all inputs to be 1 in order for 1 to be the output. So that gives us column D. Let's look now at the next gate, which is a NOT gate. NOT gates have a single input. In this case, the single input is D, the column we've just worked out. And what a NOT gate does is produce the opposite of each input. So every 0 becomes a 1, every 1 becomes a 0. And we can see here that D is 6 zeros followed by 2 1s. So E will be the opposite of that. It will be 6 1s followed by 2 zeros. So anywhere there's a 0 in column D, we have a 1 in column E. And everywhere, the last 2 rows, where there's a 1 in column D, we have a 0 in column E. Let's look finally at the OR gate at the end. Now we have to be careful here because we're not using the 2 rows immediately to the left of Z. We're using column C, which we haven't so far used, and column E, the one we've just worked out. And again, we need to remind ourselves of the rules for OR gates. An OR gate will produce a 1 or a positive output as long as at least one of its inputs is 1. So as long as there's not 2 zeros, then we're going to be fine. We're going to have a 1 as our output, if that is perhaps what we're desiring in our system. Could be the other way around, but as long as we know which is which we're looking for here. So if we have 2 zeros, C and E are 0, we'll get a 0. In all other cases, we'll get a 1. So if we go through it row by row, we can see in the first row C is 0 and E is 1, so we've got a 1. Then we've got 1 and 1, 0 and 1, 1 and 1, 0 and 1, 1 and 1. Then we've got to be careful because I might think maybe they're all 1s. In the second last row, C is 0 and E is 0. So we do have a 0 for Z here. And then in our very final row, we've got 1 and 0. So we have 1 again. So with the exception of row 7, we've got 1s in every column. It's 1s in every row for column Z. We have to be careful there in order to make sure that we're accurately checking what columns are giving us an input and following the rules for that particular logic gate. And that concludes task 2, question 4.